Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan Kabir Zawaluddin. Number matrix DD2800032. So today I would like to talk about the introduction of computerized gear system experiment. A computerized gear system experiment explores the dynamic and performance of gears controlled and monitored by computer system. It typically involves setting up gear mechanism connected to sensor and actuator, which are then interfaced with the computer. Through the setup, various parameters such as gear speed, torque, and efficiency can be measured and analyzed in real time. This experiment offers insight into how computer control reflect the behavior and efficiency of their system, providing valuable learning opportunities in engineering and automation fields. That is all for me. Thank you.
Assalamualaikum, my name is Marsha Naima binti Ismail Naim with the metric number of CD20217. The observation of the computerized gear system is gear with different size produce different motor speed at routine per minute. Each block gear, which is same size gear and different size gear, are too heavy. Higher speed gear set 1 and gear set 2 is 165.7 and 331 routine per minute, respectively at 700 speed of motor. Gear 3 has the lowest value than Gear 1 for each set of experiment.
Hello, my name is Martin and my matrix number is DD220030. I will present about the procedure of our experiment. So let us start from the experiment 1. The experiment 1 is about the same size gear. So firstly, the gear set 1 is connected with the controller and motor, and the controller is switched on. Then the speed is slowly increased at the controller until 100 revolution per minute is reached, and the system is left to stabilize for about 10 seconds. Then a thermometer is used to test the rotational speed of the gear by pointing the beam pointer to the reflector, and the speed is recorded in table 3.2. And the experiment is repeated by increasing the speed of the controller to 200, 300, 400, 500, and 600 and 700 RPM respectively. Then the whole steps are repeated by replacing the gear set 1 with gear set 2, which the gears are in different size, and it is same as in experiment set 1. The speed of the controller is increased to 100, 200, 300, 400, 500, 600, and 700 RPM respectively, and the results are also recorded in table 3.3. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Dr. Rakim and I'll be presenting the results for a video presentation for computerized gear system. So we have two sets of results, which is the stage gear with the same size gear, and the second one is stage gear with different size gear. We are using tachometers to calculate the speed for gear 1, gear 2, and gear 3. So for this first set, we have the speed for gear 1, which is 23.4, 6 RPM and 1.24 RPM for gear 2 and gear 3. And then we calculate the gear ratio, which is for data and experimental value, which is 0.23, 0.05, and 0.01 respectively. And then we calculate the gear efficiency that we get, which is for gear 1 is 1, and the same as gear 2 and gear 3. So for set 2 of the results, we got the speed 46.1, 11.2, and 1.67 for gear 1, gear 2, gear 3 respectively. And then we got the gear ratio for data and experimental, which is 0.47, 0.11, and 0.02.
Hello and good day, sir. My name is Junlin Jaji, and I will be presenting the conclusion part of this experiment. First of all, after calculating the theoretical and experimental gear ratio, we find out that they are basically identical, which is a positive sign since it indicates that the gears likely have an accurate numbers of teeth as designed. The gear mesh properly without significant friction or slippage. And also, it shows that the measurements using the tachometer were relatively precise. Next, we calculate the output speed at gear 3 and the output torque at gear 3 for gear set 1 and gear set 2 and compare it in overall. We found out that gear set 1 has a consistently lower gear ratio across all stages compared to gear set 2. Apart from that, gear set 1 exhibits slower output speed at gear 3 compared to set 2 for the same input speed at gear 0. Lastly, gear set 1 delivers higher output torque at gear 3 compared to gear set 2 for the same input torque. For the potential error of this experiment are limitations of the tachometer and friction within the system. The recommendation for this experiment, first, maybe we can expand the experiment, like use more different gear configuration to explore broader range of ratio and efficiency. Secondly is to increase the data efficiency by utilize data acquisition software for streamlined data collection and analysis. That's all from our group. Thank you for lending us your ears.